Welcome to my class, my dear students. Quadratic inequality. Our objectives. At the end of this video, you should be able to illustrate quadratic inequalities and solve quadratic inequalities. Am I true? Tell whether the following statement is true. Number 1, 5 is greater than 2. Number 2, 3 is less than 10. 3, 8 is greater than or equal to 9. 4, 10 is not equal to 10. 5, 5 is less than or equal to 5. Here are the answers. Number 1 is true. Number 2 is true. Number 3 is false. 4, false. And number 5 is true. Which are not quadratic equations? Number 1, x squared plus 9x plus 20 equals to 0. 2, 2s squared plus 9s is greater than or equal to 10. 3, a squared equals 2a plus 22. Here are the answers. Number 1 is a quadratic equation. Number 2 is not a quadratic equation. Number 3 is a quadratic equation. What is quadratic inequality? A quadratic inequality is an equality that contains a polynomial of degree 2 and can be written in any of the following form. Ax squared plus bx plus c is greater than 0. Ax squared plus bx plus c is less than to 0. Ax squared plus bx plus c is greater than or equal by 0. Ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers and a should not be equal by 0. Remember, the following are inequality symbols: greater than, less than, greater than or less than or equal. Here are examples of quadratic inequalities. First, 2x squared plus 4x plus 2 is greater than 0. Second, a squared minus 9 is less than to 2a. Third, w squared plus 4w is less than or equal by 10. Take note, if a number line is divided into three regions, the two numbers that divide it are what we call your boundaries. If the boundaries are indicated with open circle, then they are not included in the set. But if they are indicated with closed circle, then they are part of the set. Example number 1. The two given boundaries is in an open circle. Therefore, we can write this as quantity negative infinity and negative 1, quantity negative 1 and 4, and quantity 4 and positive infinity. These are what we call the interval notation for each region. We use parentheses if the boundaries are not included. Example number 2. In this example, as you notice, the two given boundaries is in the closed circles. Therefore, I can write it as open parenthesis, negative infinity and negative 1 close bracket, open bracket negative 1 and 4 close bracket, open bracket 4 positive infinity close parenthesis. Remember that we use brackets to indicate that the boundaries are included. We always use the parentheses for the negative and positive infinities. Example number 3. In this example, one of our boundaries is in the open circle, and the other boundary is in the closed circle. Therefore, I can write this in the interval notation as the quantity negative infinity and negative 1, open parenthesis negative 1 and 4 close bracket, open bracket 4 and positive infinity close parenthesis. We use brackets to indicate that the boundaries are included. We always use parentheses for the negative and positive infinities. Remember, an interval is part of the solution of inequality if a number in that interval make the inequality true. How to solve quadratic inequalities? To solve for the quadratic inequality, follow the following procedure. Step 1. Express the quadratic inequality as a quadratic equation in the form ax squared plus bx plus c equals to 0, and then solve for x. Step 2. Locate the number found in step 1 on the number line. They serve as the boundary points. The number line will divide into 3 regions. Step 3. Choose one number from each region as a test point. Substitute the test point to the original inequality. If it holds true, then the region belongs to the solution set. Otherwise, it is not part of the solution set of the inequality. Step 4. Write the solution set as interval notation or show it as a graph. Example number 1. Solve x squared plus 7x plus 10 less than to 0. Solution. Step 1. Transform the following inequality into quadratic equation. X squared plus 7x plus 10 equals to 0. Factor the given equation. Quantity x plus 2 times the quantity x plus 5 equals to 0. Equate both factor by 0. So we have x plus 2 equals to 0 and x plus 5 equals to 0. Move positive 2 to the other side of your equation. That's why we have x equals negative 2. Move positive 5 to the other side of my equation will give us an answer of x equals negative 5. Therefore, the two boundaries that we have is negative 2 and negative 5. Step 2. We use open circle for negative 2 and negative 5 because they are not part of the solution set. Take note, we use open circle if the symbol involves greater than or less than. We use closed circle if the symbol involves greater than or equal or less than or equal. Step 3. Now, let's find out what are the test points of our quadratic inequality. Remember that this test point will be substituting to the original inequality. And if it holds true, the region is included to your solution set. Otherwise, it will not be included to your solution set. Now, remember that our two boundaries are negative 2 and negative 5. How to get for the test point? So I'll be getting one number to my first region. In this case, I will get a number before negative 2. So I get negative 1. The second test point is from the middle region, and that will be a number between your two boundaries, which is negative 5 and negative 2. So in this case, I use negative 3. You can also use negative 4 as your test point. And for the third test point, I will just be getting one number after negative 5. In this case, I use negative 6. Therefore, negative 6, negative 3, and negative 1 is test point for each region of the inequality. X squared plus 7x plus 10 less than to 0. Then, we'll be having quantity negative 6 squared plus 7 times negative 6 plus 10 less than to 0. Multiply negative 6 two times by itself. So that we have 36 minus 42 plus 10 less than to 0, or 4 less than to 0, and that is false. Let's try negative 3 as our test point. Negative 3 squared plus 7 times negative 3 plus 10 less than to 0. Multiply negative 3 by itself. We have 9 minus 21 plus 10 less than to 0, or negative 2 less than to 0, and that is true. Last test point is negative 1. Negative 1 squared plus 7 times negative 1 plus 10 less than to 0. Multiply negative 1 two times by itself. So we have 1 minus 7 plus 10 less than to 0. 4 less than to 0 is false. Step 4. We can conclude that the solution set in the middle region of the number line graph or interval notation we have the quantity negative 5 and negative 2. As you notice on our graph, we use broken line to indicate that the number is not part of our solution set. Take note that the only number in the shaded part is included to your solution set. Example number 2. Solve and graph the given inequality. 2x squared minus x is greater than or equal to 15. Solution. Transform the following inequality into quadratic equation. 2x squared minus x minus 15 equals to 0. Factor the following equation. Quantity 2x plus 5 times the quantity x minus 3 equals to 0. Equate both factor by 0. 2x plus 5 equals to 0. X minus 3 equals to 0. X equals negative 5 halves, and x equals positive. Step 2. We use closed circle for the values of the variable because they are not included. So our boundaries is negative 5 halves and positive 3. Step 3. Find the test point of the following boundaries. Our boundaries is negative 5 halves and 3. Negative 3, 0, and 4 are the test points. Substitute them to the original inequality. The original inequality is 2x squared minus x is greater than or equal to 15. Substitute one by one the given test points to the original inequality. Let's substitute negative 3. 2 times the quantity negative 3 squared plus negative 3 is greater than or equal to 15. Multiply negative 3 two times by itself. Then multiply it by 2. So we have 18 minus 3 is greater than or equal to 15. 18 minus 3 is 15. 15 is greater than or equal to 15. True. Next one, substitute 0 to the given inequality. 2 times 0 squared plus 0 is greater than or equal to 15. 0 is greater than or equal to 15. False. The last one, substitute 4 to the given inequality. 2 times the quantity 4 raised to 2 plus 4 greater than or equal by 15. 32 plus 4 is greater than or equal to 15. 36 is greater than or equal to 15. True. Step 4. The solution set is the quantity negative infinity negative 5 halves close bracket is union to open bracket 3 positive infinity close parenthesis. As you notice with our graph, we use solid lines on the boundaries, which is negative 5 halves and 3 because they are part of the solution set. Therefore, the middle region is not part of our solution set. Thank you.